So guys, next we'll consider the IUPAC rules for naming aldehydes and ketones. So first, aldehydes are named by replacing the E in the parent chain alkane with Al. So if I should have propane, the corresponding aldehyde should look like this: propanol. So I'll replace this E with an Al. Alright, so having said that, the second rule is that the aldehyde functional group is given the first location and the number is not indicated in the name, since the aldehyde functional group is always at the end of the parent chain. Alright, let's recap this. So secondly, the aldehyde functional group is given the first location and the number is not indicated in the name, since the aldehyde functional group is always at the end of the parent chain. So for instance, if I should have CH3, CH2, CH2, and CHO. So when I look at this, I'll see that I'll have 1, 2, 3, 4. So what's alkane has 4 carbons? That's butane. But in this case, I have the CHO functional group, the aldehyde. So I'll simply name this as butanol. So this is how simple it can be. Alright, so the next rule: when the CHO functional group is attached to a ring, the suffix carbaldehyde is added, and then the carbon attached to the group is taken as the first carbon atom. So for instance, if I have this, so I'll simply name this as cyclohexane carbaldehyde. So notice that this is cyclohexane. This is a cyclohexane, a cyclic ring of 6 carbon. So now notice that I have my aldehyde functional group here. So now it is now simply named as carbaldehyde. So what if I had perhaps, let's say, a methyl over here at this carbon? So notice that if I have a methyl here, I'll have to consider the point of attachment of my CHO functional group as carbon 1, and then I'll count. Now if I count from here as 1, now here becomes 2, and this is 3. So this will be 3 methyl cyclohexane carbaldehyde. So I'll go ahead and write this: 3 methyl cyclohexane carbaldehyde. Now notice that if I should number this other way around, 1, 2, 3, 4, 5. I'll get a higher number here, so this will be at 5 methyl. So you know that usually what we want is to get as least number as possible, so I'll have to maintain the lowest number I can possibly. So I'll start here as 1, as 2, and then here as 3. So I'll simply have 3 methyl cyclohexane carbaldehyde. So that's it about this. I'll go ahead and make one more example and we'll look at the next rule. So let's look at this example. If I have this, so let's say I have and then I have this, so this is CH3 and this is O, this is H. So if I have a compound like this, now remember that my priority should be at this point where I have my functional group. So now this is the carboxylic acid functional group and it should take the place of the first carbon. So if I count from here, I'll have this as 1 and then I'll have this as 2. Now remember that if I count from here as 1, 2, 3, 4, 5, this will give a higher number, so I have to count this way 1, 2 to maintain the least number for this. So what molecule is this? This is methyl. So if you look at this structure, it is in a transform, so I can simply say trans. Now this is at carbon 2 methyl cyclopentane. So this is cyclopentane carbaldehyde. So that is it about that. So let's go ahead and look at the next rule, which is for ketones. So ketones are named by replacing the E in an alkane with an ONE. So when I replace an E with an ONE from an alkane, I'll have a ketone. For instance, instead of having a propane, I might have a propan 1 on. Now notice that I remove this E and put an ONE at the carbon 1. So let's look at the next rule. Now we say the carbon bearing the ketone functional group is given the lowest possible number. Now for instance, if I have okay, and I have this, and I have this CH3 and CH3. So if I have this, I'll see that I have my ketone group here. So if I number these as 1, 2, 3, 4, 5, you will notice that my ketone will be at carbon 4. But if I number this way, 1, 2, 3, 4, 5, you will notice that my ketone group will be at carbon 2. So as such, I'll have to number it this way. So when I number it this way, I'll check this. This is a 5 carbon compound, and the 5 carbon compound is propane. So I'll have to remove the E and then replace with ONE. But at what carbon is this? Carbon 2. So I'll have 2 ONE. So this is propan-2-1. So this is how I can simply name my ketones. So the next rule: when ketones and aldehydes are present in the same compound, the aldehyde actually takes the priority and then assumes the parent chain. The ketone is therefore named as a substituent, that's oxo. Now, for instance, if I have a structure like this, now this is 1, 2, 3, 4, 5. So this is 4 oxo pentanal. So this is just a simple way for naming this compound. So let's recall that this is an aldehyde group, and as such it should be placed in priority. So I'll see it as 1, then this 2, this is 3, this is 4, and this is 5. So 5 is pentan, and then this is the suffix for the aldehyde group, and then I'll name the ketone group as a substituent, that's oxo. And what carbon is it attached to? That's carbon 4. So I have 4 oxo pentanal. Alright, I'll go ahead and wipe this. So we'll consider the next rule. Now, for compounds containing 2 aldehyde functional groups, the location numbers of both functional groups are omitted because these aldehyde functional groups are expected to be at the end of the parent chain. So the suffix dial is then added to the parent chain. So for instance, if I have this O and H, so this is okay, this is O and H. Alright, so if I have this is 1, 2, 3, 4, 5. So this is a 5 carbon aldehyde having 2 aldehyde groups at both ends. So I will simply call this pentane dial. So this is how I can name this compound. So what if I had this I'll have 1, 2, 3, and 4. So this will eventually be butane dial. So this is how I can simply name aldehyde groups with 2 functional groups. So for compounds containing 2 ketone functional groups, I can actually locate the number of both carbonyls and then indicate with the suffix dione. So for instance, I can say this is having a ketone group here, this is having a ketone group here. So now let's count this 1, this is 2, this is 3, this is 4, and this is 5. So even if we count in the reverse manner, 1, 2, 3, 4, 5, we'll get the same result. So now let's notice that I have my ketone and carbon 2 and carbon 4. So I can simply name this by adding the positions of the ketones and then now naming the compound and adding dione. So this is a pentane, so I call this a pentane dione. As simple as that. So over here I can have, let's have one more example. Let's say I have this and then I have this. So this is at carbon 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Now let's note that I can't number these in the reverse form, because if I do that, I'll have here as 1, 2, 3, 4, 5, 6. So I'll have higher numbers for my functional groups, which I don't want. So with these, I'll have a ketone at carbon 2, a ketone at carbon 3, and then this is a 6 carbon alkane, which is a hexane. So I'll call this 2,3-hexane dione. Wow, this is getting more interesting. So alright, next we'll consider the IUPAC rules for naming carboxylic acids and its derivatives.